Alright, that means that it's time to get started with today's video about the mean value theorem. You've seen this picture before, this one right there. Yeah, that's the view from my front porch. Remember, coffee, dog, morning, summer, that sort of thing. It's not really about the mean value theorem, but I digress. So we've done this in class. We drew a continuous differentiable function that started at 1, 3, that's 3. 1, 3, not to scale, and ended at 5, 3. So we started here, we ended there. We drew a continuous differentiable function, and Raleigh's theorem told us that at some point we must have a place where the slope of the tangent line is 0. I'm not drawing good slopes of the tangent line, so if you go back to this, this is an excellent picture of Raleigh's theorem. If I, say, oh good, look from here to there, same height, or there to there maybe. Begin and end same height, some point the tangent line 0 if you tip your head the right way. So we're not talking about Raleigh's theorem today. What we do want to talk about is, however, the question. Okay, oh, well, that's the question. Y prime equals 0. Maybe there's another one. So that's Raleigh's theorem. We have this. We've talked about it. And so I'm just going to blow right through that because you have these notes already. But the real question, maybe it's here. There it is. Found it. I was whispering. That's why you didn't hear me. What if the f of a is not equal to the f of b? Sorry if you adjusted your volume to hear me. And then I yelled. But what if that's not the case? Okay. So there's this mean value theorem that says something like this, or as Troy would say, it says exactly like this. If f is continuous and differentiable on a closed interval from a to b, then there exists a value of c that's between a and b such that the f primed of c is equal to the f of b minus the f of a over b minus a. So it says draw a picture. I'm going to help you with that. Okay, so we've got a closed interval. We've got a continuous differentiable function, which I'm just going to draw something like that. Okay, and the f of b minus the f of a over the b minus a, that's my change in y over my change in x. Okay, that's basically the slope. Right, so boom to boom. Let's get a real line in here. Yeah, that'll be fun. Okay, right there. So that's this side. That's all this stuff over here. Okay. The other side says the f primed of c. And what's the f primed of c? Yes, it's the derivative. Okay. And what's the derivative also known as? Yes, it's the slope of the tangent line. So I could say, and I'll try to do this. Let's see if I can make it work. Yeah, pretty good. I'll have to move that into place. Okay. That at some point, the slope of the tangent line is equal to the slope of this line here. And if you remember, this is called a secant line. And the other one is called the tangent line. And the slope of the tangent line is the derivative, and this is just the slope. Right? So the slope of the tangent line equals the slope of the secant line. That's what the mean value theorem says. I'm sure I have something pithy in the little hidden box. And so is Raleigh's theorem really just a special case of the mean value theorem? I think so. Because in Raleigh's theorem, the slope of my secant line is 0, and the slope of my tangent line has to be the same. So there we have it. So mean value theorem, it's another one of those existence theorems. It means that the theorems tell us that it exists, but it doesn't necessarily tell us anything else but how to find it or anything like that, but it just seems like that is the case. So let's use the old mean value theorem to find if there is a place where all this stuff happens when we want it to. Okay, I did that. So mean value theorem says at some point, it's a weird box, at some point the slope of the tangent line, right here, is equal to the slope of the secant line. Okay, slope of the tangent line, slope of the secant line. So the slope of the tangent line, derivative, 3x squared plus 4x. Okay, at some point, that's equal to the slope of the secant line, which is the f of b. That's b. That's a. So we plug b into my little equation. So the f of 2, do that as a little sidebar up here, is 2 cubed. Write it all out. Plus 2 times 2 squared minus 4. So 2 cubed is 8. 2 squared is 4. 4 times 2 is 8. So your 8 plus 8, 16 minus 4, which is 12. So the f of b is 12. The f of negative 1 is negative 1 cubed plus 2 times negative 1 squared. Remember, parentheses are free, so use them liberally. Cost you when you don't have them, when you forget them. Negative 1 cubed is negative 1. Negative 1 squared is 1. 2 times 1 is 2. Minus 4, so I've got 1 plus negative 1 plus 2 is 1. Minus 4 is negative 3. So 12 minus negative 3 over b minus a, which is 2 minus negative 1. Top 12 minus negative 3 is 15. Don't write that way for some reason. And 2 minus negative 1 is 3. So this whole thing turns out to be 5. So then we're left with, when is 3x squared plus 4x equal to 5? Okay, and we know to solve that, we have to make it 3x squared plus 4x minus 5 equals 0. And quadratic formula, quadratic equation, quadratic whatever. Let's see if we can make it work again. What did I have? I had 3, I know was a. It's really bad that I can't remember from that one. Plus 4 and negative 5. Okay. B was 4. C was negative 5. Bingo. Those are my roots. 0.78629 and 2.11. So 7.786. So that happens. X equals 0.786. And x equals, what was the other number? There we go. Negative 0.2119. X equals, this doesn't work. X equals negative 0.2119. Okay? So that means that those are both in my interval. So that means twice it happens that the slope of my tangent line is equal to the slope of my secant line within that interval. So these are both perfectly good answers. So if I were to draw a picture of this, I probably should have done this fast. I think let me pause and get the calculator set up so you're not waiting for me. Well, you are, but you don't even. All right, I'm back. You know, I left, I know. So that's the graph, and you can see that it happens that, let's see, if we draw in the secant, can I do that from here? Well, let's see. Probably should have planned this in advance. Let's go to that. Let's go to that. And then I can draw in the secant line if I have myself a pen. Okay, my secant line when x is negative 1 is right there. When x is positive 2 is about there, so there-ish. Okay, and so my tangent line apparently has the same slope, certainly has the same slope there, and there's got to be another place where it has the same slope that I'm missing, probably because my negative 1 is really badly off. Might be over in here someplace. Let me let's reinvestigate. Let's go back to that. That's beautiful. I'm pausing to make sense. Aha! I figured it out. Okay, this negative 2.119, it's not my interval, right? So that doesn't make any sense whatsoever. So if I go back to my graph right here, so there's negative 1. Pretend I'm drawing a line. There's 2. So you can see right here, my tangent line is going to be perpendicular or parallel there. It probably would happen again over here someplace. Right? I could draw a tangent line probably at about there, and it would be parallel to this secant line, but it's not in my interval. So that, my friends, is why that is how it works, and I'm not going to belabor that point anymore. Perhaps I should have just been quiet. All right, so here's my lovely page. All right, so let me tell you a story. Okay, here's a little story about a guy driving a car. Okay, driving a car on the interstate, 2 o'clock in the afternoon. Here's the car cruising along. Realizes there's an officer of the law. Slows right down to 55. Okay, going 55 miles an hour. Passes officer. Okay, cruises down the road. Cruising down the road. Realizes there's another policeman behind the tree, and slows down immediately to 55. Okay, we're at mile marker number 11. The time is now 2:04. Okay, little red car keeps cruising along, and pulled over by officer number 2. The car or the person asks, "Why are you pulling me over?" "Because you violated the laws of calculus." It's a good story, isn't it? So let's see what happened. Why did our friend get pulled over just for driving along following the speed limit? Well, because the officers had been instructed in calculus, and in particular in the mean value theorem. So what they realized was that, first of all, our good friend traveled how many miles? 5 miles. And how long did it take our good friend to travel 5 miles? Why, it took him 4 minutes. Right? 5 miles in 4 minutes is how many miles per hour? So how many 4 minutes are there in an hour? There are 15 groups of 4 minutes, right? Because 4 times 15 is 60. So if I multiply this by 15 and this by 15, I get the number of miles per 60 minutes, which is like miles per hour. 5 times 15 is 75 miles per hour. Okay? So what the officers told him was that your average speed was 75 miles per hour during this time when we weren't seeing you. As you were cruising along down the road, your average speed was 75 miles an hour. Even though when we saw you, your instantaneous speed was 55, and your instantaneous speed here was 55, at some point along this interval, you had to be going 75 miles an hour. So you, sir, have violated the laws of calculus in this range. Because the mean value theorem, basically, when we're talking about, let me go back to here, we're talking about the tangent line and the secant line. The tangent line is my average rate of change. Average rate of change, which is what we always learned about before, of change. And the secant, or the tangent line, that's my instantaneous rate of change. Instantaneous, I'm not going to write that all out. Instantaneous rate of change. So at some point, back to our friend in the red car, he had to be going 75 miles an hour because the mean value theorem says at some point your average rate of change and your instantaneous rate of change have to be the same. Okay, so average rate of change equals your instantaneous rate of change. Good Lord. Equals the instantaneous rate of change. At some point, instantaneous rate of change is the derivative, f prime, the slope of the tangent line, all those things. Remember the connection, they all go together, IROC, f prime, derivative, they all mean the same thing. So that's what the mean value theorem tells us, and that is why our little red car got towed away to traffic court, and our friend was no longer able to drive it. So, keeping the roadway safe with calculus. That's our little story so far. So, those are going to be what you're going to look at. Pay no attention to that or that. And thanks for watching. Don't violate the laws of calculus. Yeah, you don't want to tell the cop your average rate of speed was this. They're more interested in the instantaneous, but sometimes they do set up this way where they're measured distance apart, and they can get you that way. So, hope you learned something. We'll talk to you real soon. If you have questions, please feel free to tell me at some point down the road, like maybe tomorrow. Okay, 13.5 minutes. That makes up for going over the other day. Average length is right around 15. Thanks.